the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRAE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRAE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, ISHRAE India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The ISHRAE exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ISHRAE.in that unfolds a panorama of information Let us engineer a sustainable future together through ISHRAE.
So, very good evening and thank you, everybody. Thank you, all the panelists and all the attendees for joining this session. As you know that today we are going to cover very interesting topic, clean room design, and we have expert speaker for this. Mr. Murlikant is there with us in the panel. This program is organized by Delhi chapter of ISRE and ISRE Institute of Excellence, and of course, without the help of a sponsor, we cannot do this kind of program. Sponsor for the day is Perfect Air, and also this program is supported by ISRE Chennai chapter and ISRE Chennai chapter. So, moving before moving forward with the presentation and introduction of Murlikant sir, I have short video of Perfect Air, which I would like to share with you. It will take hardly 2-3 minutes.
Perfect Air, an organization established in 2000, is the fastest growing engineering, procurement and construction company with expertise in clean room systems. Perfect Air undertakes turnkey projects for clean room solutions including HVAC, electrical, structural engineering and automation. Clients rely on us for our experience and competence in setting up their clean room system. One group, Perfect Air, 20 plus years of experience, 50 people team, 100 vendors, 200 clients. A vision to create world-class perfect clean room facilities by ensuring innovative cost-effective technology, best implementation practices, high-quality products and dedicated team to meet dynamic industrial requirement in adherence to all international standards. Our mission, to be India's fastest clean room making company, using advanced technology and professional management with commitment to total customer satisfaction. Our values, that we only believe to serve the perfect. Perfect Air hosts one of the best young dynamics, hard-working innovative teams under one roof. We have over 50,000 man-hours of experience affording you industry-leading performance. Perfect Air team is dedicated to providing the best combination of quality products, on-time delivery and timely completion. Our time-tested corporate philosophy, expertise and rich experience has stood us in good stead in the highly competitive market. From concept to certification, Perfect Air delivers world-class turnkey cleanroom project services. Our project management process covers all steps in the delivery of a high-performing production environment. Our turnkey project management process, project planning and estimation, project design, project installation and commissioning, project validation, project training, turnkey project, turnkey manufacturing, laboratory facility engineering, turnkey facility design, which include facility, production, manufacturing, research labs, hospitals, OT and commercial. Our turnkey project covers clean room project, biosafety labs, HVAC project, commercial, residential, malls, office space, production engineering project, MEP project, electrical project, firefighting project, automation, BMS project, solar air conditioning project, civil project. We at Perfect Air use latest, innovative technology solutions for all industries. Clean room technology, maps, HVAC, validation. We offer wide range of products verticals like ducting, piping, AHU, chiller, puff panel, electrical panel, HEPA filter, air shower, pass box, sanitization chamber. Industries go for a specific class of clean room and HVAC system according to their operations. We have versatile success story of project completion for many industries like pharmaceuticals, microbiology and research labs, food and beverages, medical devices, automobile, semiconductor, nuclear, hospitals, defense, nanotechnology. We have 20 years of experience, 200 plus happy clients. India's fastest clean room making company. One-stop solution.
Hello.
Yeah, please.
Yeah, thank you, everybody. And of course, we are also thankful to all the annual partners of Delhi chapter of ISRE. Special thanks to gold partner LP Aeroflex, silver partner Briar DRI, Syscam, and annual partners Standard Refrigeration, Advanced Wall, Paramount Polytreat, and membership partner Aircon Engineers. So, without any delay, I request Mayor Fajal sir to introduce the speaker in front of us, and we will proceed with the PPT with Murlikant sir. And all are requested to put your question in Q&A section. Further, we will take it at the end of the session. So, over to you, sir.
Thank you. So I'm grateful to the DCI chapter who has given me an opportunity to introduce one of the most talented, Mr. E.R. Muralikant, on the subject clean room design. Mr. E.R. Muralikant is a mechanical engineer with more than 35 years of wonderful experience, presently working as a freelance consultant, providing consultancy services in HVAC, fire protection systems, storage tank, utility and chemical process, piping system. He's associated with some of the leading architects and MEP consultants in Chennai, mainly for clean rooms and hospitals. His core areas in HVAC are clean room design, low RH systems requiring lower than 15% RH, process flue, gas treatment for chemical factories, dust control systems for powder handling processes, and HVAC integration with fire protection systems. He has been working with different industries in the past 35 years, mainly with chemical factories and pharma industries, where indoor as well as exhaust air quality both are very, very important. He has given some training programs in the past few years at ISHRAE Chennai chapter and also directly to some reputed HVAC companies in Chennai. All topics on clean room and RH for industrial applications. He has written 5 articles on various topics in ISHRAE Journal for the period 2021. We are definitely going to enhance our knowledge with this wonderful presentation on clean room design. We welcome you, sir, for your speech, and we also very much thankful to all the well-wishers, sponsors. We also ensure maximum visibilities to all our valuable sponsors to the fraternity by organizing such kind of programs online or offline. So we welcome Mr. E.R. Mulikan to present his presentation. Thank you.
Yeah, good afternoon, all of you. Thanks for the introduction. I sincerely thank ISHRAE Chennai, and all the people for giving me an opportunity to come into this program. I'm audible, all of you, please?
Yeah, very much, sir.
Okay. So before going to the program, I would like to just brief you. Here we will not talk much of engineering. We'll talk of more of science, less of engineering. I hope most of the participants in this program have done some clean room jobs in the past. If you have done, probably it have been easy to get the message appropriately and go into better. If somebody are learners, I would request them to post the questions end of the session. Okay. Now, shall I share my screen now?
Yes, please.
Yeah, thank you. As visible screen?
Yes, sir.
Okay.
Yes, it is.
Yeah, this is basically disclaimer. Information provided in this is based on experience and exposure what we have been having in the past. With the knowledge whatever we are acquired in the past, we are sharing with all the people. And there may be some application-based requirements on case-to-case basis, which may be explored by the people of the relevant field. Now, clean rooms, the design matters. This word, how it is coined, design matters. Most of us people here are basically from science background. And what is a matter? Anything that occupies space is matter. This is what the basically clean room actually talks about. We have two segments. One is wanted matter and unwanted matter. In a clean room, wanted matter is the people who are need to work there, the machineries, the lightings and services. And unwanted matter is anything that is not required to be present in the room is unwanted matter. So basically we talk of aggregation of wanted and unwanted matter. So again, as per science, anything that occupies space is called matter. So here we're talking of the matters which is necessary for our process, and unnecessary things can be removed. That is the simple definition for a clean room. Now, topics we'll have this: requirements in a clean room, possible contaminants in clean room classification, design principles, typical AHU for clean room, energy for clean room, UVGI, and AHU installation. Initially, the few 5-6 chapters will be on outline where I'll be briefing about some of the various things which most of us will be aware. But when you go further deep into the system, we'll come across various features. One is energy saving. One is after this Corona episode, and many people have the thought how to go over to UVGI. And one last thing is the AHU installation. Knowingly or unknowingly, people have been putting AHU the way they want, wherever they want, and what is the impact of AHU. Many people are still not aware. So the last two pictures, UVGI and AHU installation, they're a very, very big subject. I'll share some of the experts from the small things, okay? And I will share the file to these participants. It is around a 12-page write-up of UVGI and around 12-page write-up of AHU installation. So after program is over, I'll send this by email to the concerned people, and we can go into that. Okay, now let us start this. Definition. Now this definition has been taken from various references. One of them is called ISPE, International Standard for Pharmaceutical Engineering. If somebody has already have some background in pharma, probably that person must be aware of what is ISPE. ISPE is the governing body which has taken inputs from ISHRAE and the various other standards to especially meet clean room requirements. When you say clean room, they are more into healthcare. ISP is more into healthcare and not in other business like electronics or some other things like that. Okay, clean room is a space meant for any activity to be carried out within the confined space that is very minimal of any internal and external contaminants, such that the contaminants has no or least interference in the activity that can bring out consistent quality of the product that is being produced in the confined space. This definition is taken from ISPE, which clearly defines the clean room concept. In simple way, the clean room should be such a sophisticated construction that doesn't allow any unwanted matter coming into the system or getting released from the system. When you manufacture something, one is you should protect something coming inside in the process, and similarly, what is generated from the process should also not go out. So either way, it has to be looked into. That is what the clean room space is. Now, examples: operation theaters, ICUs in hospitals, medicine manufacturing sections, electronic parts manufacturing sections, space research labs, solar cell manufacturing. These are the various industries where clean room is extensively used. Many of us are aware of this small recommendation. I will just touch it. Requirements in a clean room shall be free of measurable size of particles as per intended specifications. This is very, very important. When you say clean room, there is a definition of the particles, which micron and what limit. First thing we should understand that shall be free of measurable size of particles as per intended specifications. Then walls, floors, ceilings shall be easy to clean. Equipment shall have easy access from all sides to clean. Many times you find that equipment below, there is some space, floor and equipment base. Unwanted material go and get parked there. So these are all things we should avoid. Equipment shall not generate particles while operating, especially Weber driven systems. Dimensional pressure shall be maintained at all times to minimize contamination from external sources. Personnel working in the space shall have clean clothing. There shall be no cavities, dead ends, pockets, etc. that can be a source of dirt collection. Metallic parts used in the area shall be rust proof like stainless steel or aluminum and many more. Now, these are the basic requirements what we saw in a clean room. Now, how does the clean room affected? Internal sources, particles generated from machines parts while in operation like V-belt or conveyor belt, oil leaks, coolant leaks, etc. Suppose you are processing some milk powder, so milk powder will fall or milk droplets will fall. These are all the contaminants which invite microbial growth. And particles generated from product like being powder, powder filling machine, liquid aerosols from liquid filling machine. Now, when you say it's a liquid filling, a powder filling, there are some possibility of powder coming out from the filling zone. It may be safe or unsafe to you when you inhale that aerosol particles or powder coming from the filling systems. So that is one thing we should also look into. Then it may be harmful, may not be harmful, depends on the nature of the product. Particle generated from moving like trolleys, metal lifts, etc. Generation of fine dust from floors due to trolley movement, man movement, leaks from utility services like compressed air, steam, cooling heater, energy pipes. Generation of particles from personal working in the area like sneezing, speaking, coughing, loose air, these internal sources that affect. Then further, peeling of wall paint, especially in the rainy season, ceiling paint, product spillage during handling and storage like drum leakage or something like that. External sources, infiltration from nearby rooms due to improper pressure difference, improper operation and maintenance of HVAC system, inadequacy in design of HVAC system. These are the various things which contribute to the deviation in the field environment. So when the system is planned for a design system, the personal designing system should understand from the end client what is the nature of operation, what are the sources that are likely to generate unwanted matter which can deviate the specifications. So as I told you, we have two matters. One is wanted matter, unwanted matter. Because anything that occupies space is matter. So the person designing the systems should interact with the client clearly, understand what are the sources of internal contaminants, because external contaminants to some extent we can prevent, but internal contaminants is very, very difficult to prevent unless we are sure the source, the nature of the contaminants generated from the source, and how to mitigate them. Now, clean room classification. Many of us are aware. Many people are always are not clear what is the clean room classification, and is always most of the times misread concept or misunderstood concept. Now, we may say that is how much particles we need. Now, when you say ISO 1, ISO, earlier we used to say class 1 lakh, class 10,000, all those things. I'll come to that a little later. Now the prevailing industry, as per the ISP norms, nothing is called as class 1 lakh or class 10,000 like that. It's all ISO grade, ISO 1, 2, 3, 4, 5, 6 like that. Okay. Now these are all in particles per metric cube of air. If a conversion metric cube, definitely you can understand this. If you're not conversion, I'll just go to next slide and explain you. These were the older ones. SI, what we generally speak now, English class 1 lakh, class 10,000, class 1,000, class 100, like that. This is by and large nowadays obsolete. Only some European countries are adopting this till now. But these are the ISP guidelines which say ISO. Okay. This is slowly being adopted by different countries, but still long way to go. But presently, many of us are aware of this terminology, class 1 lakh, 10,000, 1,000, and 100. Now, here is where the actual miscommunication comes. When you say class 1 lakh, people do not even know what should be class 1 lakh. Actually, we have to validate 0.5 micron particle per cubic feet of air. Okay. Now somebody says for me 1 micron this much, 5 micron this much, 2 micron this much. Let us not go into those debates. We should be very crystal clear. If somebody is saying class 1 lakh, it is 0.5 micron only. Why it is not 1 micron or 2 micron? If your 0.5 micron is well within the limits, naturally it is expected in normal condition, the particles higher than 0.5 micron doesn't come into the room by and large. Okay. Now, again, there is a confusion about interest in operation. I'll come to that also. Now, here, if you clearly say at rest and as operation. Okay. Now, when you go back to this previous one, ISO, ISP guidelines, they do not talk of anything on rest. They talk of only in operation. What is the difference between at rest in an operation? When you say at rest, the machines are there, the HVAC is running, but machine is in standstill condition. No production going on, no maintenance going on, everything is standstill. That is at rest. Now, when you say in operation, the production is going on, the people movement is there, material charging is there, machine discharging is there, and it is normal production area. Now, so when people in the earlier days used to talk, what class you want at rest, at operation. No, this is now obsolete. If you people are referring to this at rest and operation, it will always lead to unwanted confusions only. Again, going back to this, ISO 1, 2, 3, 4 up till 9, it all talks of only in operation. That is a normal procedure when the production is going in full swing or operation theatre patient is on the bed and some operation is going on, whatever circumstances are there. It's all in working condition only and not standstill mode. So the designers, please be aware that do not be miscarried or misunderstood by what is class 1 lakh or whatever number you put. It's all nowadays in operation only. Why it is operation? Why on not rest? See, when it is in operation, between room A to room B, people will come. They'll come along with some flying dust in the footwear or like that, and some trolleys will come with material required for charging or discharging like that. So all these things contribute to the internal contaminants. So moment you say internal contaminants are high, you are deviating from the actual desired conditions. So that is why it is always desirable and advisable to see you're always maintaining at working conditions only. Now, in India, many people are conversant with class 1 lakh, but if you say class 10,000 or class 1,100, many people are still not aware. Again, in 1 lakh, practically in tablet capsule systems, they are still not clear whether to go into operation or at rest. That the standards are refined now, it is in operation only. That means a rest condition, you will be getting 10,000 or further below. In running condition, you will be getting class 1 lakh. This is how you should establish. Somebody may think at that condition getting 10,000, I'm overdoing. No, you are not overdoing. You are doing what you want. In 1 lakh means in operation and not in rest. Again, 0.5 micron only. I would like to give a small example here. A few years back, we had discussed a client where he was telling about a 1 lakh class, and he showed a sample a printout of the particle count report in which the 5 micron was within limits, whereas in 0.5 micron, other things were much beyond limit, infinity. And here the client was saying, see, 5 micron is within limits, so my class 1 lakh is qualified. I said, no. In a 10th standard class, if your 5 subjects are there, if you one subject you pass, the rest all fail, means you fail only, na? You nothing but 10th standard is pass. Similarly, the guide 0.5, 1 micron, different particle sizes are defined. So if you are attacking 0.5, everything automatically comes in line. You are not supposed to debate on 5 micron or 1 micron. So that's the way we should practically tell the examples to people. So Even somebody comes and shares with the thermal report of the viable particle count, you should tell them this example, they will immediately understand. See, 1 micron means this 0.5 micron is not in line, but 3 micron, 1 micron in line. The semi in the facility is qualified. Okay. Now, major clean room applications, class 1 lakh is pharma, food, milk powder, operation. In operation theaters, there is always now a lot of debate going on. Should you go for class 1 lakh or class 10,000 or something like that? Some people say, no, we should go for class 1 lakh. Some people say, why should you go for class 1 lakh? This is still a lot of debate going on, but as of now, the present scenario, as per various guidelines prescribed, 1 lakh in the operation theater is a must. Again, in working condition, not in static condition. So people should take care by this. And class 10,000, yes, again pharma, we have got like that, and class 1,000 and class 100. Some electronics do require class 100 also, but difference between pharma and hospital industries and other clean room like automobile or this solar is just like that. There's a although you may pass in the particle count, that means the visible particle, 5 micron, 1 micron, and all. But in non-pharma industries, the exposure to biological limits is not critical. So in operation theater or in a drug manufacturing room, you have to validate the microbial content also in the room. Because suppose one patient was operated in the 3 o'clock in the morning and room is left like that, some blood stains may be on the room, which can promote microbial growth. And when the second patient is coming into the room, probably that microbes may infect the patient. And similarly, in pharma manufacturing area, there are some flying powders going here and there, which may remain there for some time. When you change product A to product B in the same room, the leftover previous batch for compounds may get mixed with the next batch. So here is where very important. Now, in one more thing is when you have this microbial count exposure. See, if you are going for a blood test or urine test, the test takes 3 days for culture report. Similarly, in the pharma and hospitals, although you're having class 1 lakh or 10,000, there's always a necessity to drag samples of the room air with exposure plates. They have got some small plates the microbiologist will keep in the room, and which he will put some number in it, and after 2 or 3 days he'll take the uh, sample to the lab, do the analysis, and he finds the microbial limits are exceeding the limits, then the whole batch is put on hold or quarantine. They go for a thorough testing of any contaminants coming into the room. So this is where the difference between a pharma and in other industries where people have a lot of requirements, stringent requirements, I would say, in pharma, because microbial load is one thing very important, which is not that much relevant in non-pharma industries. Now, design principles. It's important to understand the classification meant for the application defined by the end user. Many times, due to inadequate knowledge by a client or designer, both the systems are under-designed or over-designed. Some cases, cost saving leads to under-design. Many guidelines mention minimum requirements. This, however, is subjective and due importance to be given to the actual application of the end user. A frequent reference to minimum also has many times become inadequate systems. Minimum is also equated to cost saving that ends up in design shortage. Now, for example, if I say the action is required as 20 to 25, okay. Now, the minimum says 20 and maximum 25. So, a client will say, I'll put 20. Why should I go for 25? Yes, his logic is correct to some extent because the cost is there, ducting cost is there, fan cost is there, everything is there. But what is the end he is going to see? Many of us must have noticed when you do heat load calculation for clean room, the dehumidified CFM may be less, maybe say 5000 CFM or so. But because of the action is required, we go for instead of 5000 CFM, go for 9000 CFM or so. The 4000 CFM is extra. Why? Because we have to have their clean in their room. What is the result of higher actions? People always have this question. I will come to the topic a little later. So, when we talk to the customers, we should always make them understand. Don't stick to the minimum always. If required, we should go for a little higher also. Now, following factors are involved in design criteria to meet the various classifications. Action is per hour, temperature and humidity, room DP, exfiltration, infiltration, internal heat load, possible source of internal and external contaminant, which we discussed a few minutes back. Now, the next slide you will see effective airflow coverage all throughout, minimal hot spots and dead spots, higher air coverage is equal to better thermal equilibrium all around. This does not include loss of air from machine exhaust that is vented outside the clean room, autoclaves, dust filters, heating tunnels, process vents, etc. Now, air changes. Just few minutes back, we were talking about this. Now, for ISHRAE 20 to 25, one more thing we have to see is the percentage Hava ceiling. It says 5% to 10%, depending on the geometry of the room. Suppose let us say clean corridor, the corridor may be 2.5 meter width or so, and maybe 15-meter long. In that case, one is a clean corridor, you have to have 20 to 25 actions per hour. But when you actually put the HEPA, you find even 10% of 5% of ceiling is not covered. Maybe 3.5% or 2% only is covered. Now, what do you do that? Now, here we have to put additional HEPA. So, these are two common factors we should always see. One is actions per hour and one is ceiling HEPA. Whichever is better. The more HEPA coverage you give, the less dead spots we have or blind spots we have. Especially suppose the corridor having L-shaped corridor, L-shape. The L-shaped end will be always subject to high parking area for the contaminants because there becomes a dead end on both sides, L-shape. So in that case, when you actually plan, you have to plan a crisscross mechanism of a HEPA and internalizer so that the water air is coming there or dust is trying to settle there, it's pulled away very easily. So again, when we go back to this, what is the minimum? Okay, he says the minimum requirements. Now, minimum says 20 atmospheres per hour. Then ceiling average 5% ceiling area. Suppose 20 square feet, 5% is hardly how much? 4 square feet, 0.4 square feet. So here where the people come into confusion. So what should I do minimum? So here we should be clear. If I say minimum, it can be this or combination of both. You may have 23 HNDs and 8% HEPA, fine, no issues. So here is where we should understand. We should not just like that say minimum is okay. I am saving on cost, I am saving on power. Fine, you may say, but can you get the result consistently throughout the year? No. Again, class 10,000 it says 30 to 50 and HEPA is higher coverage than class 6. Here it is. So like that we have. Now when we talk of the LAF area, here is always a confusion. What is that percentage HEPA you are saying in 35%, 70% LAF, non-LAF? Here is always a confusion. For example, operation theatre in a surgical room where the patient is put on that operation table. That area will be close to class 100 because it is 100% laminar flow on that area. However, the room surroundings will be class 1 lakh. So effectively, when you match those things, it will be around 30% or so. That is ceiling area of that HEPA above the operation table, which is a laminar station, and other surrounding area. It will be around 35-75% will be overall HEPA coverage the ceiling. It is very tricky. So when you say blindly this value, we should be able to realistically understand what we are talking about. These things, many guidelines actually do not represent any picture to show this. They have just given some text and few indicative sketches, but we have to really look into how it is to be done and what way it is to be done. Now, air changes per hour. It is often compromised on air changes per hour considering medium required. Often the message is fire for higher air changes and fan motor size increase, hence the capital and running costs. In clean room concept, this statement becomes invalid in many times because our priority is to maintain the clean area and not focusing on the energy billing. I will show you the examples in the coming papers how much the fan kilowatt per chiller kilowatt is playing role by increasing or varying the air changes. In clean rooms, higher the air changes, better the clean environment. Higher air changes always keep the particles in motion and don't allow them to settle in different parts of the room. Therefore, higher air changes are beneficial. For example, you must be knowing there are two types of wind. One is breeze, one is storm. When you say breeze, it's a slow movement of air. Slow movement of air will give some comfort, fine, but it will not pull all the dust coming in its way. So heavier particles always remain to settle here and there, especially at the corners and the dead ends wherever possible. That is breeze. In Hindi, you may say Sheet Lahar or Lahar. Okay. And in Tamil, they say Tendral. And when you talk of storm, in Tamil, they say Puyal, and in Hindi, may Tufan. So when you have a storm, heavy wind is blowing, it will not allow any particle to lay down or settle any part. So that is the importance of clean room. When you are having a higher activity per hour, it will not allow the particle to settle anywhere. It will be pulled constantly. It will have a constant scavenging effect on all surfaces comes in contact with the air movement. So higher the air changes, the higher the clean you will get. One more thing is higher air changes also reduce the delta T of the return air, lowering the cooling coil load. This is very, very important. Suppose you are heating something in a room, say iron box or something heating. When you are having high flow of air passing through the heating source, the air touching the object will have very less delta T gain because air flow is very fast. One more thing is the heat will take more time to come to the object. But when you're having a low activity, the object will become hot very fast and the delta T of the air across the object will also go high. Now, by increasing activity, what we are doing is we are reducing the delta T of air and the other effect is the chiller load also falls down. So this is very, very interesting thing. If suppose if we are sitting in a classroom and explain this in a board, fine, okay, no problem. I think you understood the concept. And similarly, humidity. Most clean rooms specify the temperature of 23 degrees centigrade and RS 50 to 55%. In certain cases, RS may be less than 50% also as per end user specifications. Importance of humidity. Here is where very, very important. Last few minutes back, we discussed about the microbial growth in a clean room. If humidity is higher and that change is also less, the heavier particles they form a bond. They'll become small laddus. So these laddu will go and sit at different places. It can be it can be biological or non-biological also. If it is a biological compound, it will promote growth of bacteria. So by having low air changes and high humidity, we are allowing more and more concentration of the unwanted matter to settle in the room for longer time. Now coming back to the same topic, what is the effect of air changes? One is it doesn't allow the particle to settle fast. It will also reduce the heat load, and importantly, it will also not allow the moisture to settle for longer time. Suppose you are putting water on the floor and the fan is switched off, it will take long time to dry. But switch on the fan, the floor will dry fast. Same thing happens here. Importance of humidity. If the humidity is more, the fine particles become wet and heavier and is not easily carried away by the flowing air. The higher concentration can result in particle count failure also. This can lead to settlement of fine dust like a ball in all cavities, corners, etc. In hospital operation theaters, this can promote growth of fungus and other microbes that can be a concern to the patient health. Now, coming back to the same topic, what is the importance of higher action is? One is it will reduce delta T, it will reduce particle concentration, and it will reduce humidity. So all three put together become a very fine associate for a clean room design. Now, differential pressure. Here is where many people probably misunderstand or misrepresent. This is the clean room, okay, corridor. Airlock is double plus, and this is minus. So air is flowing from here to here and here to here. This is airlock is positive. Here clean room is positive. So air from clean room is going to airlock and from airlock to corridor. Okay. Now all these four things have got different applications. Next one is clean room is double positive. Okay, there are two clean rooms here. Clean room within clean room. So this clean room is positive, double positive. Airlock is double positive. Here, this is the most critical area where critical work is being done. That means air should always leave this room and not come to this room. Although they may be having same class 1 lakh or something like that, but nature of operations, nature of working inside may be a little different. For example, in a, let us say this is your manufacturing room, and here is your packing room for a tablet, for example. This is a tablet granulation making area, and this is a tablet putting in a bottle. Okay. Now, if you are having double positive here, it is good for you because the flying granule powder will not come here. Okay. It may be same product, but what will happen is this flying particle can stick onto the coated tablet or something, and it may be visible as a foreign particle, unidentified particle, while going and checking in the lab. When you sample in the lab for the profile of tablet and all, it may give a false indication of some particle is stuck onto the tablet. It may be same powder, doesn't matter, but it becomes a unwanted question. So in this scenario, it is always better to have a double positive here, so that whatever the granulation powder or something will not carry forward here. This is one concept. Now, other concept is here. Okay. Now, this for steroids or something like that, for end product, where we have to see the is always in a better condition. So here is one application which very rarely comes, of course. From here it will be coming like this. Now in clean room, one is the very important is orientation of doors. Okay, now this is double plus, so door will close always this way only. Suppose somebody by mistake put the door other way, then this double plus will always not meet the purpose. And here, this is double plus. So door will goes into here, and this door goes into here. Here also, door orientation is very important. Many of the clean room, wherever I associated with or designed by checking the client's drawing, we always come across these type of misrepresentation of doors. And again here, this double positive, so door is closing this way. Okay, here, this is double positive, door is closing this way. This may be coming from same source of AHU or different AHUs. That is different. But the point is the door, how you exactly plan the doors. That also plays an important role to have a perfect air balancing. Suppose you have not captured this door properly or define the door properly, and in infiltration, exfiltration will go for a big problem. Your conditions will always be within border range. You'll not even get when you validate this system. You'll always be seeing what does the fun AHU filter have you cleaned everything, but still you will never get the result within the permissible. They'll always in border. It will not even match many times. Now, why DP is required to maintain internal cleanliness at all times? Clean room shall be provided with airlock as shown in the previous slide. The airlock is a barrier to prevent less clean air coming into the clean area. It advisable to have same AHU for corridor and the clean room. This will ensure that airlock does not take unwanted air from nearby air. That can add to contamination in the clean area to personal and material passing through this airlock. Okay, however, now exfiltration, infiltration, as we discussed just a few minutes back, depending on the door orientation, if your door is wrongly put, it will be a problem. Now, all clean rooms have positive pressure, mainly the airlock with respect to nearby lesser grade clean rooms. In many instances, the combined airflow of particular AHU, a part of the air is lost into the nearby corridor or less clean room from the airlock due to DP. This loss has to be quantified and supplemented with additional fresh air quantity. If not considered, then the system DP shall not meet properly. Adjusting dampers to meet DP will lower the desired air changes and disturb the particle count also. Now, design principles we are clearly aware. The airflow required for to meet the heat load is X. Airflow required ACH is Y. Just few minutes back, we just talked about air changes. I'll go in deeper on this point now. It is observed that X is in many cases less than Y. That is, dehumidified CFM is say 5,000 and air changes is 6,000. So you are going 6,000 just because the air changes required is high. Higher air changes will reduce the heat load. How? We know Q is equal to MCP delta T. For heat load Q kilowatt, we have XCFM of air. For heat load Q kilowatt, we have YCFM of air. X, Y is greater than X, hence DT for Y is less than X. Simple. Got the point? See, this is mass of air. Okay, if I'm increasing this X to Y, delta will fall down. Okay, chiller basically behaves on the delta T of the water. I'll explain you in the next coming pages. Now, design principles we just discussed few minutes back. I'm refreshing once again. Internal, external contaminants. Internal means contamination from machine like wheels, conveyors, leaking lubricants, etc. Contamination from process, powder, liquid aerosol, process vapors. Contamination from personal, utilities, trolleys. Okay. Generally, the average particle generated by mechanical means range between 10 micron to 50 micron. These particles can be easily scavenged by giving higher airflow rate. These particles are heavier by trolleys or like that. They will not be pushed away with low air changes per hour. You have to give a flood of air. You have to give higher air changes because they are heavy. They will not be easily pulled away. So we have to be keep on giving higher air changes. Now, it is necessary to have filters in the return riser. the particles are heavier and remain close to the floor, maybe 20-30 inches maximum from floor level. In clean rooms, ISHRAE razor with 10 micron filters placed at appropriate locations along the wall. As we discussed few minutes back about the HEPA ceiling coverage, while planning the HEPA ceiling, you should also be able to understand where the returner risers are, and preferably you should put them close to the one is doors, because near the doors you got plenty of people and metal coming and going. So that is one place where maximum accumulation is possible. And if you're having a pass box, again you're having a lot of accumulation near the pass box. You're having a conveyor belt like for tablet printing and blister packing. You have a what they call conveyor belt. So there again a lot of particles will go and sit. So these are the areas where you have to prioritize while giving the retinal risers. Otherwise, what will happen? Those area will be full of concentration, and when you do microbial count or something, those areas will be having deviation. So a designer should visualize and understand where to put the retinal riser. One is aesthetics, one is desired places. Okay, only then we can have a proper maintenance of the clean room. External contaminants, we have discussed about this. Fresh air. Now, fresh air is one of the main things which adds to more and more problem. What happens is, in many of the factories, HUs, the filters are the least attended, least prioritized component. Now, if you find fresh air filter is totally damaged, but still people running with the so-called fresh air filter. So when you're having a fresh air filter damage condition, what is the purpose? Purpose defeated, because all the high load will go and sit on the down the line, 10 micron, 5 micron and all things. When the system is choked with dust, there will be not much action, there will be starvation. Room DP will fall down, the temperature will vary. So this is one of the main thing. I will share the AH installation pages, okay, after this. It will be interesting to know how the filters play a role. Now, filtration. To have clean air, we need higher action rates and good filtration. Fresh air port shall have insect mesh, followed by 20 micron. Within the AHU, 10 micron, 3 micron, 5 micron filters shall be considered. Many people ask, why should I put 3 micron? Standard doesn't say 10 micron, 5 micron, or 3 micron. They say what's filtered air. Yes, question is correct. Now, let us understand sequence of filtration. Particles about 20 will get trapped in the 20 micron fresh air filter. Okay. Now, between 20 and 10 will sit here. Between 10 and 5 will sit here. And suppose you are not having 3 micron, any particle less than 5 micron will directly go and sit in the HEPA only. That means what you are doing, you are reducing the HEPA filter life. By putting 3 micron filter, I am increasing the HEPA life. This is one of the important thing which people do not know. So to save the cost or to save the age cost or like that, people say I do with standard doesn't call for 3 micron. So why should I put? So standard doesn't call. The standard says you have to have a good mechanism to meet the desired air particle count. That's it. Now how you achieve it is our design. So we should recommend putting 3 micron also. It is called as EU9 filters or F9 filters. So both are same, equal to 3 micron only. You can consider that. This will give a better healthy HEPA life. And depending on the classification, you have H12, H13 or 14 alpha filters also if required. Now here is the biggest debate. Many people ask, HEPA in the AHU, is it okay? Not okay. The clean room, the answer is no HEPA in AHU. Why? See, generally filters are designed for a velocity of 500 fpm. And in HEPA it is 90 fm, maximum 120 fpm. Say that 100 fpm is the HEPA recommended air velocity. Now, if you put the HEPA filter in the AHU body, which is having 5 FPM velocity 5 times, what will happen? The filter get punctured very fast because 5 micron filter you're having, suppose you're not having 3 micron, the particles less than 5 micron will escape with high velocity. They hit the HEPA like a bullet, and what will happen? It get punctured. So the purpose of putting HEPA in the AHU is not at all correct. So people, if somebody is asking why should I not put HEPA, please don't put. Tell them very clearly. HEPA will get punctured very fast. It's not meant for that high velocity. Now, the percentage coverage HEPA we discussed. I am repeating once again how much stringent it is. If you're not following these guidelines, then you will be very difficult to get the clean room classification throughout the life. Now, typical AHU scheme. Now, this unit we are done for pharma, which is having a powder passing system. Okay. Here we are having this fresh air 20 micron filter, then 10 micron filter. Why I am putting 10 micron filter here, I will brief you. Okay. I will explain this slide. Then 5 micron filter here. Okay. Then we are having a AHU fan. Then having a cooling coil, mist eliminator, electrical heater because steam was not available there. Boiler was not available, so we go for steam. Then 3 micron. Then it goes to the room. Here having some powder passing area. So this comes to a powder dust coloring system. It will come here like this. It will go to the dust color cyclone and this will go back to the AHU. Now this is a blow through AHU. Normally people see coil here and then the fan. We always recommend the other way, fan, then the coil. The advantages I will brief you one by one. Now let us go through the sequence of filtration here. Now from the room, let us go start from here and go one by one. From the room, we expect particles maybe of more than 10 micron, or sorry, less than 10 micron, because we have a 10 micron filter in the return air room. So some particles below 10 micron are expected to come here, the first thing. Second thing is this dust collector, it is also pulling some particles. This will be trapped in the dust collector. And many people leave to the atmosphere, depending on the nature of the product, we will take to the atmosphere or recycling, depends on the product. Here for this job, we are putting it back to the AHU because this is having a lot of cold energy. So most of the dust is trapped here. So altogether, we expect the particle to be close to 5 microns, a little more than that. So this filtered, I mean this dusty air, which is supposed to have particles above 5 micron, will get trapped here. Okay. Now next comes the fan. It pulls the filtered air. Okay. What does cooling coil do and mist eliminator do? Here is a purpose for that. We talk of only cooling coil as a energy bank. It has got one more purpose also. Now this particle is above, say below 5 microns, whatever travels here, it will get trapped in the cooling coil because it does the work of wet filtration. It does the work of wet filtration. That means you are improving the filtration efficiency by putting this coil after the fan. Now, next is mist eliminator. Why is it required? When you are cooling the air, the moisture is a byproduct coming from the air. This moisture, if not properly treated, will fly into the room, okay, and increase humidity. So this mist eliminator traps the flying water droplets. Now coming back here, from here we're getting the air which is having particle less than 5 micron. Because of the wetness on the coil, becomes wet filter. The air gets filtered, so it becomes much cleaner. Then you have this mist eliminator, which protects the moisture going forward. Then you are having this heater, then 3 micron. Now, by putting this, the load on 3 micron is less. Again, down the line, you are having HEPA, further load is less. So, in all this scenario, our HEPA life is much higher than expected because you are doing series of filtration. Now, let us look a few minutes about the fresh air component. This fresh air has plenty of unwanted things. We don't know what is size. We have an insect mesh to stop mosquitoes and other things coming into it. Then have 20 micron filter. Then 10 micron filter. Now, the expected air quality after 10 micron here and expected air quality after here, both are likely to remain the same in case of particle count because we are having 10 micron here, 10 micron here. So ultimately, particles less than 10 micron are expected to fall here. This is the design we go for a clean room. Suppose you are not having a dust collector, then only this component is removed. The rest will be as it is. Same thing for class 1 lakh, 10,000 and so. Okay, for class 1,000, the action is will be higher. So CFM will be higher. For class 1000, actions will be higher, CF will be higher, but the sequence of operation will be similar. Only AIQ size will go bigger and bigger because of the CFM capacity. So now what is the we are doing here? By doing such series of now when you're having very low load on the filter, your air quality is much better. When you're having very low moisture carry forward into the room, your microbial colony forming is also very less. If you're not putting this mist eliminator, most of the water will fly down here. Now coming back to the question, many people have the coil before the fan. It is called as draw through. This is in the blow through mode. That is draw through mode. Now, in this case, in this diagram, there is always constant thrust of air pressure acting on the U trap. So what will happen is the water will always be running away. It will not stay here. Suppose there is a constraint in the technical floor to take the U trap. No problem. You can take this line out of the building and give U trap there. That's it. That's fine. It'll work. In other system where you have the coil before the AHU, what happens is it is in vacuum. You need adequate head of water to overcome the vacuum force. And in practically in technical area in the first floor or second floor, you will not have much long distance for the pipe to travel and slope is not given properly. So what will happen is this always in vacuum pool, this drain tray will most of the time get flooded with water and this water will go into the room and humidity is always a concern. So this is the advantage having always a blow through units. Even for comfort also we recommend blow through, we never go for draw through. Then maybe a question, blow through length is bigger or like that. No, it's absolutely nonsense. Okay, whichever way blow through or draw through, the AHU length remains the same. That is separate topic altogether, which I am not talking here. Now, energy for clean room. We discussed whether the action is higher will affect the energy or not. Say, for example, we have a clean room requirement here. Standard square meter area, height is 3 meter, volume is 300 cubic meter. Now, act index is say 40 in option 1, that is 7,000 CFM, and 60 is 10,000 CFM. This is one small sample calculation. Now, how does it affect? Internal load, say 6 kilowatt, that is 1.8 TR is the dignified load. Fresh air is approximately 2000 CFM. Okay, now see here, 7,000 is the CFM, pressure is 2,000. Just watch carefully. Okay, ambient is 39 degrees centigrade, everything put here. Enthalpy is this much. No, peak pressure load, this is 60 R. Okay, now energy for clean room comparison. Heat load is 6 kilowatt, dehumidifier is 2000, at 40 ACH it is 7000, and 60 is 10,000. Heat load delta T is 5.5, here it is 2.82, here is 1.85. For dehumidified CFM, when you are actually repairing 2000 CFM only, you repair only 5.5 degree expected delta T on the air. By going 40, it is 2.83, and by 60, it is 1.85. Okay, delta T of water, heat load is same, this is same. Okay, the heat load here, water, if you go for this CFM, this 4.5, here it is 1.92, and here is 0.76. So effectively what you are doing, the chiller load is falling down. By increasing the air changes, the heat captured by the air is very, very low. So delta T of air is very, very low. In return, the chill water delta T is very low, and your action delta T of water is very, very low. So you get a very good saving. This may vary on case to case basis. This is one of the examples I am telling you. Now, again, chiller load, okay, on water temperature, assuming air cooled of 1.3 kilowatt per TR. 6 kilowatt, again, heat load is 2.14 kilowatt is 0.95. Okay. For same chiller, 1.43 you have to run for this 0.95 kilowatt only. So energy saving is there. Okay. And fan 9.8, 10.2. Okay. Now, one AHU you are talking about, you have multiple AHU. This fan kilowatt is very negligible, it will become very peanuts. Whereas your chiller takes a lot of energy compared to a fan. So many people always probably misunderstand saying that the clean room higher activeness will lead to higher fan power. Fan power definitely will be higher, not denying that. But running expenses compared to chiller and fan is cheaper than chiller. Now, UVGI. After this Corona episode, a lot of people must be understanding or having a lot of questions about UVGI. No, I'm just sharing few examples. I'll give a separate write-up of this. Now, UVGI, suppose you're having a split AC. In this, we'll cover clean room also in the coming pages. This is a AC room. UVGI is kept here. Maybe two ceiling mounted AC is kept here. What are concerns? Air in the room is poorly filtered because split AC doesn't have much filtration. Deposition of dust and moisture drops UV is high. Okay, for example, in house you see the toilets are having a lot of dust after some days. You don't clean daily, but you have clean once in a while. Same thing happens UVA also. So in the due course of time, system intensity reduces because of high accumulation of dust with moisture. Since they are poorly separated, the possible penetration of UV lamps into cavities room shall be less because there is no proper circulation of air. Items like furniture in the room also shall interfere in the penetration of UV to the farthest point. Having some furniture here, it will not go to the longest part. Now, the location, quantity, coverage in the UV system also plays important role to ensure maximum coverage throughout the room. Since there is very less fresh air in the system, the microbial concentration increases faster. Okay, providing adequate exhaust air units at different locations and giving equivalent quantity of fresh air can dilute the microbial concentration. This also reduces sick breathing syndrome. Okay, now go to the next slide. We have adaptable units, more or less same here. It's very less pressurized. Here also you have a very less circulation. Okay. More, here also the filtration is ductility is very less. No control of humidity. So here also the problem is not met as expected. Okay. Now case 3, you are having a AHU provided supply return air. Okay. Here we are having a very good air circulation throughout the room. Okay. Hence less deposition. Okay. Here humidity is better controlled, less moisture accumulation. The same room, if you are seeing here, it is ductable AC. Here it is split AC. So, but when you go one by one, you find this is much better than the previous two. Now, here some effect is there because the air circulation is much better than the other two ones. But here the deposition, everything is a concern. Now, it's a long one. When I send you the paper, you can, because the time is also running out, I'll not be able to talk much on this. Okay. Now, can the AU be placed in AHU or in the duct? There are 4 examples. Okay. Draw through AHU, UV mixing film. I think it is not visible here. UVGI is here. UVGI is here. Okay. Mixing plenum. Here is one option. The other option is at the discharge. Okay. Just see if here it is before the fan. Okay. Now this is a draw through mode. Okay. In draw through mode, yes, already told you it has got a lot of water accumulation because of vacuum. So the UV will not be getting much effect down the line. Okay. If you put it here, again the water carry forward will be here. This will be again one more issue. Then in blow through mode, if you're having return plenum, slightly better because there is no much water coming into contact here. Okay. And one more thing, fresh air is coming here, it will be dealt directly here. Okay. Then we have in the after cooling coil. Okay, this is also one option. This is one option in supply plenum. Okay, various options you have seen, and the last one is the best option in having a AHU with recirculation mode, for example. Okay, now here what we have, if you go through slightly here, see there's always a R velocity of 500 ppm also across the all the components here. Now here it is supposed to be by and large cold air, which is maybe 20 degrees centigrade also. So when this cold air comes here, it takes some time for the microbes to get warm before being killed because UV also generates some amount of heat energy. Okay, so here it's very vicinity contact of the system, so the proper UV intensity is probably less. Whereas you put here, you are not concentrating on the area and one. You are distributing different. Suppose you have in 3 different rooms. If you put in the duct of the 3 different rooms, it becomes better way because from here to here, there is an almost negligible water moisture carry forward here, negligible dust carry forward here. So settling of this is very minimal. This will having a better effect. But above and all, putting the UV in the room is much beneficial. Again, even case to case basis also. When I send the UVGI report, will come to me. Now I'm going to the other files. Before I go to other files, if any few questions somebody can just ask on this, then we'll go to UV and other 2 files, please. Hello. Hello.
Hello, yes, sir.
Yeah, before I go to next 2 pages, I would like any questions to come forward till now what we discussed.
Yes, sir. We have a few questions.
Please.
That is, first one is from Mr. Sundar. He's
Yeah.
asking that please share the room requirement for carbon composites manufacturing for automobile.
See, See, automobile manufacturing, I told in the starting, it's although comes some of the components do come in clean room. Many of the places 1 lakh is generally adopted. But the thing is, practically, if you go and see, many people don't have proper control of material and manpower coming into the room. There's no proper airlock and doors are not properly closed like that. Just they want some clean room, that's it. So if you are asking for automobile, I would say that 1 lakh many people are, they ask and you maintain. But when you talk of carbon content, you may, I think you are talking about the flying dust in the room. Am I right? Or something else, carbon content in the room. What is the question? Can you repeat that? Some carbon.
Should we move to the next one or
See, carbon composites. Carbon composites.
carbon composites manufacturing for automobile
The carbon is
requirement?
actually a dust generation system. No, I am not conversant of this carbon composite manufacturing. I have not any knowledge of what the system looks like. So unless you give me some proper requirement, I will not be able to comment on that because something I not come across this type of installation.
So, should we move to the next question?
Yeah, please.
Yeah. So anyway, Mr. Sundar, you can mail us other, I mean, for detail for this, what you are exactly asking.
Next question, please.
What's difference between putting HEPA filter in HU in air terminal?
Yeah, this I already discussed in the presentation. So putting in the AHU, please assume don't put because the particles below 5 micron will come high velocity, hit the HEPA like a bullet and puncture it because HEPA is designed for an average flow velocity of 100 fpm, maximum 120 fpm. In the AHU, we are having 500 fpm. So this high velocity particle will go and puncture the HEPA very fast. If somebody is recommending this, please don't take it. Please throw. So I don't want, I don't recommend. If you want, let him put. But from your side, be clear, we will not allow putting HEPA in the AHU body.
Yeah. Next question is how to safeguard agent UVGI?
See, UVGI, I mean, his question is probably importance of UVGI or how to safeguard. I don't know, I'm not able to answer the question. But I'll send this 5-10 pages of UVGI. I'll explain you after this question answer. Around 12 pages are there. I'll just briefly show some of the features. Then I have circled the paper to all these people, to ISHRAE Delhi people. You can circle to the participants. After going through that, if they have any questions, please come across.
Sir, next question is how we maintain differential pressure in design side or it done through damper control only?
Yeah, this is very, very important. See, many people do not know how to do the infiltration, exfiltration calculations. They put some thumb rule and say this much air is coming and going. In design stage, we should be able to capture what are the possible sources of air gain or air losing. Suppose your room is negative pressure, it will pull air. If it is in the positive pressure, it will lose air. That much pressure you have to add, number one. Number two, you are having pass bars cutouts or conveyor cutouts or something like that. And there also there is always a pressure variation which will promote the bleeding of air. In design stage itself, we should be able to capture as much as data possible to compensate for the losses. Otherwise, what will happen is after commissioning, no, you will never get the proper DP. You may adjust the damper at one room, but fan is same. From room A to room B, it will go. That's all. And that room DP will go high or low depending on the room volume and activeness in that particular room. Damper adjustment for DP is only during commissioning stage you can do little of adjustment to settle the things. Otherwise, you not touch it. So if design is adequately captured with all the losses, then probably you can do it. I'll show you, if time permits, end of the show, I'll show you a small calculation about differential pressure in the room, how the pressure is going in or coming. how much CFM is leaking or taking. Okay, if time permits in Excel sheet, so that you can have a better aware. Next question, please.
We have taken all the questions that what we have received in Q&A section, sir. Please.
Okay, so I'll go to the other two things now. Okay, about the UVGI and EH installation. Visible slide, blue slide visible.
Yes, sir.
UV germinal radiation. Okay. Now, this around 15 page write up. Now, some of the pictures we saw here, I'm putting here once again. Okay, we split AC. Okay, it can be VRV alone or whichever way the source of cooling system. Now, I'll go to directly the comparison of all these things. See now, here are the comparisons. Visible, all of you?
Yes, sir. It's visible.
Yeah, okay. Now, parameter, moisture content set hold up in the, see, we are in draw through and blow through. Okay, two different types, and where the UV is positioned. We are not talking of UV in the split AC and other things. We are talking of only related to the air handling systems. Moisture content set hold up in the coil section very high since coil is in vacuum of fan. If U trap and drain slope not proper, excessive moisture carried forward into the conditioned space, resulting higher markable load. Here also same thing, okay, because it is in the
Sir,
markable.
only this is slide. This blue slide is there, or anything else is there? I mean,
That text is not visible. Text is not visible.
text is not visible.
Text is not visible. Let me make it a little larger, probably. Now visible.
No, sir.
Oh.
Actually, only blue slide is coming.
The text is not visible.
Yeah, text is not visible. Actually, I thought you were talking about only blue side. Anyway.
No. Text actually the blue background, so
Yeah.
your text is not visible. Okay. How to do? Okay. I'll do one thing. Let me see some other way of seeing it. Now visible?
Still not, sir.
Oh. I'm sorry, I didn't expect this to happen. It is visible to me. I don't know why. Okay, no problem. I will send this paper to you. Okay. And now, why I don't know it's not visible to you? It's surprising. Because this is in a blue background at the pages. Let me reshare once again and try. Let me reshare again and try. Now visible?
It's opening still.
So screen sharing is paused. करके आ रहा है, why it is paused?
Take a minute, just. Screen share. You have screen share authority, sir.
Yeah, it is showing your screen sharing is paused. That's coming. That message is coming. I don't know how it's coming.
Just. Please share it again.
Now it's showing. It should say again. It's showing same thing. Fast. I don't know why something wrong. Your sharing is fast is showing. I don't know why it is. Sharing is fast. Resume share. I'm clicking again. Nothing is happening. Showing now. Resume share. Click कर रहा हूँ कुछ नहीं हो रहा. I don't know why.
काम करता है, मैं आपको ना वो दोबारा डिस्कनेक्ट करके कनेक्ट करता हूँ.
Sharing is fast. Sharing is fast.
प्लीज शेयर इट अगेन सर. दोबारा मैंने आपको होस्ट बना दिया है अभी.
अब शो हो रहा.
सर ये पीडीएफ फाइल आ रही है. यस.
टेक्स्ट शो हो रहा है.
टेक्स्ट कुछ नहीं दिख रहा है. हाँ अब दिख रहा है. इट्स फाइन.
टेक्स्ट
अल्ट्रा
दिख रहा है.
सेलेक्ट किया दिख रहा है.
टेक्स्ट दिख रहा है ना. ठीक है. Maybe some problem earlier. Okay. No worries.
ठीक.
Thanks.
हाँ.
Thanks. Good. Good. Okay. Now let me go to the comparison directly now. This now see screen now.
Yes sir, it's fine.
No, okay. Maybe some connectivity, some issues, God knows. Okay, something else.
Might
Okay.
be sir, might be there.
Okay.
Anyway.
Now this is visible to all now. Option 1, this table visible to all.
Yes sir, every is fine. Option 1, 2, 3, 4 all is.
Yeah. Your text you're seeing, no? Fine. Good. Okay. Now this 6 options we discussed few minutes back in the PowerPoint. Okay. A moisture content state hold up in the coil. Now the first 2 options are draw through where the coil is kept before the fan. The coil is always subject to vacuum suction by the fan. So what happens is here the most of times high moisture accumulation is possible, which will result in carry forward of the water down the line. This is the biggest drawback in draw through. Either put UV or don't put UV, this water hold up will remain. Okay. In option 3, mixing plenum, no hold up since positive pressure from fan always pushes the water towards the drain. Almost zero hold up, hence less microbial growth. So all these having the same because are all blow through mode. Now dust accumulation and sludge formation. Since condensate hold up is high, as briefed above, sludge formation with dust can promote algae growth, especially in monsoon. In both these things, here it is nullified. Okay. So all whatever the contents are sitting in this AHU chamber will have a direct correlation with UVGI. Suppose you design a UVGI for the say 10,000 CFM of air, it will only try to kill the germs in the air, but whatever the germs present in the accumulated water, which nobody knows, and you can't quantify also. That means in both these conditions, UVGI becomes nullified. It has no role to play because water, the microbes sitting in the accumulator water will be there only. Now, next, UVJ performance due to dust. Again, fresh air adds more scaling on UVJ, resulting in poor life and performance. I just few minutes back I told you many cases fresh air filters totally damaged. But still, what happens? The dust will come and settle on the UVJ, which becomes less effective. Compared to this, if you put in the U in the supply plenum, performance with respect to dust it is better because pressure load is less. Okay. Now same as option 1, better than option 1 to 4. Okay. Here putting between fan and coil. Here in the mixing plenum, between fan and coil in supply plenum and room branch jar. So whichever location you choose, these are the various effects. Okay. If you're putting before fan and coil, what will happen? Pressure by and large filter. But if you put after the things, As I told you, coil does a wet filtration effect. So the flying dust will already get trapped onto the coil surface and only cold air will go. But again, cold air also will not allow the temperature to rise faster in UV. So the effect killing of germs is less. Now UV gel performance due to moisture. Heavy water condensation leads to water scaling and the UVGI. So life is low. Again, here also same. No water accumulation. Since it is the prelam, mixing prelam, dry dust scaling is more on UVGI, resulting in low output. Although it is beneficial, other culprit is moisture with dry dust. Okay, with dust will form a scale. Here is better, again best of all options. Okay. Now these are the 6 diagrams where we have evaluated where to put the UVGI. In all the cases, it's always beneficial to put in the branch duct because the concentration of air is less. It's having much filtered air. There is very less moisture coming in contact with the UVGI. Its performance is much better. So these are the few findings about the UVGI. There are other cases also you can put in the room or so many other options also, but we are talking of clean room AHU, so I am sticking to that only. The methods to improve UVGA performance. So when you go through this paper, you will come to know because a lot of things are here to be thoroughly studied. Okay, so I will when you go through this, you will have a better idea. Now let me go to the other thing where I am telling of this. So one important point right here is see performance of UVG duct mounted. UVG's branch duct was shared. This is more effective when compared to mounting on the edge chamber. See here is the colonies where you form. Okay, the air is coming here. What will happen? Air will go hit and bounce here. There will be a small dead zone here. Okay, whichever option blow through, whatever ultimately this is the culprit area. Where there will be a very less effect. What will happen is you are hardly after the AHU body you are making a small duct. This is bigger, this is smaller. So there will be backlash. And this backlash means it will promote the accumulation of colonies here. Okay, and these colonies after some time become immune to UV light. Okay, this will carry forward into the room. Now, putting it in the room in the branch duct, this particular thing is nullified. Okay. Now let me go to the AH installation one. This is another file, very interesting one. I will show that also now. You are seeing this file? Hello?
Still not open, sir. Yeah, now it's coming.
Okay. Installation of air handling units. These are air handling units. Okay. 20 micron, 10 micron, fan motor, cooling, miscellaneous heating element, 5 micron, supply air, return air. Ventilation unit, pressure, 20 micron, 10 micron, supply air. Okay. This picture you able to see?
Yes, sir. Fine.
Okay. Some facts about atmospheric air particle concentration. PM10, it's 10 micron, is given in the figure. Okay, Indian air quality monitoring. Okay, up to 2014, it has been after the data yet to get. 10 micron, the average particle concentration is in the range of 100 to 150 micrograms per cubic meter. Okay, 10 micron particle size. range of 100 to 150 micrograms per cubic meter. Now, this does not talk of the construction area nearby or like that. It's general area it talks of. Some construction is going on or some like that, road work, something like that, demolition, something like that. Those are not captured here. Okay. According to WHO other standards for indoor air quality, long-term exposure PM 2.5 particles accounted and monitored in certain places. Okay. Particles bigger than 2.5 are not considered determined indoor air quality. Reason, if the indoor air quality within limits of 2.5 micron, it automatically defines that particles bigger than 2.5 are negligible since the filtration is proper and well maintained. Okay. Now here I want to slightly emphasize on the AHU, where to install, how to install. Now, if I put in the AHU in a, wherever in an open terrace or like that, some of the figures I'm here giving here. Now, when you come to now, 2010 micron felt damaged by high vacuum along the edges because of bonding between media and glue getting applicable filters kept in fan section. When filter is cleaned with high pressure compressed air, then also this is damaged. What are the reasons why the filter is getting damaged? These are the various things. Okay, when you are having high velocity or high abrasion because of high dust particles, this is how it actually happens. This is the punches. This is the choking, choked. Now, 2010 Famicom cassette type. Here the gap is there, so a lot of dust escape. Okay, so because it's a very long one, what I'm telling you is just an outline. When you keep the AHUs open to the atmosphere, this is how the timeline happens. Filter grade, filter size, area square meter, airflow, safe pressure drop, approximate quantity, airflow 80% choking, time required 28 days. Okay, if you are keeping in the open 28 days, the fresh micron will get choked roughly. Okay, now 10 micron filters 21 days. Okay, and 5 micron filter again 21 days it will take roughly. Okay, this is kept in the closed room. Okay, now if I keep it open to atmosphere, the 4 days just choked. Why? Because of the particle size very high. In 4 days it will get choked. We keep it open. Then 5 days. 5 days. So this is the importance of keeping the AHU in the open or closed room. This is a big article, around 10 pages are there. So I would share this with the people. Okay. So wherever you put the AHU, either in the roof or in the nearby walking area, as long as kept open to the atmosphere, this is where you have actually come across. So which is better, cleaning in every 28 days or every 4 days? You can, this is there in front of you. So either go for clean room or non-clean room. Always emphasize to put the AHOs in the closed room. Okay, I know it's very clear that it will take some space. You have to give a room for that and with a lock and key and so many other things are there. But what the filter is the most negligent part in any factory. They don't clean properly or don't maintain properly. It is choked and keeps on running, and one fine day it goes out of control. People argue just one last week only I cleaned. Today you are kept in the open. Then every 4 days you have to clean. Or probably every daily you have to clean, some construction work going on. And if frequent cleaning also will reduce the lifetime. What many people do is they use compressed air to clean the filter, which is wrong. because the filter doesn't find FPM and you don't have any control of compressed air, what will happen? It will go and puncture all the filter, or it will along the filter framework, it will the glue will come out. So what will happen? Lot of leakage will happen. So this is the, while designing your clean room AHOs, even comfort room also, please emphasize that please give a good room for the AHO and share this with the people you are talking to. See, if you are ready to clean every 4 days, fine, no problem for me. And tomorrow you should not tell every third month you are asking new filter. Why? So that's the reality. The figure showing filled with water and dust. So actually, 20 micron has got a larger scaling, 10 micron less scaling, then almost zero scaling because we are having a mist eliminator and this cooling coil does the function of a wet filtration. So like this, and wet ventilation. So these are the various things we should always blow through AHU and draw through AHU again. So this will get choked fast. In draw through AHU, you are not getting the advantage of wet filtration because it's kept here, return is coming here. In blow through, return is coming here, you are getting the advantage of wet filtration. So people should understand by going for blow through and draw through what is the major impact. You are getting a better cleaner air because it does a much better filtration because having wet filtration. So these are the some of the things I would like to explain you. And one is the difference between fan and filters. Okay, some people argue that draw through will take more space like that. No, it's not. Either way, it has equal space only. 30-degree angle before the first component. What we generally do, we just blindly put 600 mm or so between fan and the first component. It's wrong. Just to cut short the AHU space or cut short the length of the AHU, we are doing this. Somebody has been doing for so many years, we are also doing this, but not correct. So this will be the actual thing. 30-degree angle should be there. AHU length will definitely go bigger, but we should demand. Again, talk will come, there is no space, the AHU room. So these are the basic things I want to share with people. So we should ask for the best and try to get the best. Otherwise, it will be very, very difficult. These two files I'll be sharing with ISHRAE Delhi. Probably they can share with all the participants. I think this is what the end is. So any other questions anybody has, please you can talk. Hello?
Yes, sir. Hello.
Any questions from anybody?
I think one few questions are left. For example, room required is 2000 CFM, 10 plus. How we maintain? How CFM will supply?
I repeat once again.
For example, room requirement is 2000 CFM. 10 plus. You don't know what.
10
10
Pascal.
plus dot. How we maintain?
You want to maintain the room pressure?
You can see in this Q&A section. I think
for X
more
room,
clarity.
required is 2000 CFM 10 plus. How we maintain house? This question I'm not able to properly guess. Okay, I will share you one small thing. Okay, about this exfiltration details. Okay, probably that will have better clarity. This we are able to see this Excel sheet.
Yes, sir.
Excel sheet you are able to see, na?
Yeah,
Okay.
we can see the Excel file.
Okay, 1 minute. Okay. Now, somebody, this exfiltration, no, I'll just show you here. These are doors here, okay? Correct? Everybody see this calculation? Yeah?
Yes, sir.
Okay. Now, this door is here. Okay, door one. Okay. Now, let me just slightly bring it further down. We'll have a better view. 1 minute. Now, this is the pressure you are seeing here. 1 mm, 3 mm put here. Okay. I'll bring it a little larger also. Pressure 3 mm put here. Okay.
Yes,
And
sir.
this dp is presently 0. Okay, this is the exfiltration of the room. Okay, I put here 2 mm. This much CFM is coming out. Okay, now this is double door. I put a single door. Single door. It's coming to 120. Okay, this 2 mm. I put here 1 mm. This much. Okay, now I put here this. I'm putting a 4 mm. This is going. This much is gaining. Okay, so this is a method to calculate the exfiltration infiltration of anything. So while doing for clean room, people should also know what is the pressure room required, what is the what you call opening of pass box or doors like that. Somebody was asking how do I maintain pressure? Okay, so actually you should evaluate. Unless you have proper way to calculate the pressure, you will not know how much air you have to take away or give into the room. So and this much pressure adding system will add to the heat load, dust
Hello.
load, everything. Yeah, tell me, yeah.
Hello.
Yeah, hearing, yeah, tell me, yeah.
Yes, sir. Please,
Yeah.
please ask your question. Not, please go ahead.
Good evening. Good
Good
evening.
evening,
Your
sir.
presentation is excellent. I
Yeah,
have a question. I have one or two questions basically.
yeah,
One is now as you are heading as a clean room,
yeah,
and now we are also consultant. We are focusing mainly on hospital segment,
yeah,
designing the OTs and others.
yeah.
We are not using the word clean room, but we are saying the indoor air quality.
Okay.
Now, there is, I know many people that even they are HU manufacturer or they are consulting with HU,
Yeah,
they are saying about the clean room. They're
yeah,
using this terminology.
yeah.
Now, can you present it now? How this industry will react on these two words as indoor air quality and clean room?
Yeah, okay. Very good question. In the starting of the presentation, I made a few points clear. ISPE, okay, International Society for Pharmaceutical Engineering, was a governing body which decide in the healthcare industry. Healthcare means hospitals and pharma, everything comes under that category only. Now, why we there see indoor air quality after this COVID things is become a different platform altogether. But indoor air quality again, what indoor quality you look for? Okay, when you say what indoor quality, you may say PM 2.5 or some number you may say. It concerns to what? It conforms to what? Okay. Now, indoor air quality is now more of a subject discussed on commercial establishments and little of office complex like that, and not in manufacturing sectors. Manufacturing sectors are different, and commercial and office sectors are different. Suppose you are having a consultancy firm like TCS or a Cognitive Center having full floor. The so-called sick building syndrome, they talk of indoor air quality, where they talk of PM 2.5 and so many other things. But how many times of the day we are exposed to outside air from morning till evening? Most of the times we are exposed to outside air. I don't know. We leave house, go to office, and come back. Maybe few at 8 hours, 10 hours in the office only. How does it contribute indoor air quality? It can't. It is very little. A few hours only. Actually, you are concentrating on that. Actually, what happens is we are talking of the patient. I mean, human protection because of this COVID other things. But when on the road, lot of dust is coming in. You are inhaling lot of dust. Any control? No. So this is totally confusing terminology by various people. Okay, when we say clean room, it is associated with most of the healthcare and manufacturing sectors only, and not other things. As of now, a lot of discussions going on. If I everywhere talking about PM 2.5, then why don't you have 2.5 in a house?
One thing,
Yeah,
in case of indoor air quality,
yeah,
we also consider mainly for operation theaters
yeah,
or
yeah,
even ICU,
yeah.
the air velocity and also the static pressure of the room.
Correct.
And as you have mentioned that heat point, and we also take consider the air stratification, whether air stratification is happening in the room. Because
Correct.
if the air stratification happens, the
Yeah.
laminar flow will not work. It will
Uh,
disturb.
uh, okay. See, there's a small difference here. See, laminar airflow basically contributes to the patient where the patient is being operated.
Patient table. Yeah, it's
Yeah.
patient table.
Okay. Okay. That is one thing. The second thing is when you say indoor air quality for the OT. See, we generally as of now people say class 1 lakh area. Fine. Generally as of now. Okay.
Hmm.
It is close to ISO 8 grade.
Hmm.
Now, as I told you at the start of the program, it is everything at operation and not at rest. Okay,
Hmm.
that means when you qualify the system at rest, it will be class 10,000, which is ISO 7. Okay,
Hmm.
now here were the little catch. When you are running the system, you will get a better air quality at the LAF and inferior quality comparatively non-LAF area.
Hmm.
Comparatively, within absolute terms, mild difference will be there. Now,
Hmm.
all these things are addressed by adequate action days and sequence of filtration. So when I
Hmm.
introduced 3 micron filter in the past few 5 years back, a lot of people opposed for 3 micron filter. When I made them aware why I'm advocating 3 micron filter is just to improve the down the filter efficiency. Now slowly the message is spread and people are taking the right spirit and putting 3 micron also in the AHU body. Indoor
Hmm.
air quality, we are talking of only PM 2.5 or whatever number you say, what of makeable count.
Hmm.
So that's where I want to emphasize. Microbial count is something which indoor is also part of indoor air quality, but not necessarily demonstrated in all applications.
Right. But again, we find few people unnecessarily put up HEPA around not 13 or 14, below that. But
Hmm.
HEPA, since there is a huge pressure loss,
Hmm.
it indirectly it allow a higher fan power to be built in the HU.
Yeah,
So
see that's required. See, that here is what the actually, see we are trying to save the patient or save the current power, energy power. What you want?
yeah,
That
energy power goes up because if
no,
someone.
doesn't matter. No, here is what I want to be. Higher action doesn't mean higher energy. Which when you're having higher fan power is much less compared to chiller power. You're talking of only one OT. Okay, whereas you're having a hospital having centralized AC, giving to ICU, giving to reception, giving to X-ray room
Correct.
everywhere.
But one thing now the people are recommending, not in India, in Singapore and others, they
Hmm.
are asking that if the 2 or 3 UTs are there, they should have a dedicated HU.
No, there's already there as per NABH. This guideline is very clear.
Hmm.
Each OT should have each one single AHO, not sharing. It's very clear.
Not
NABH is very
sharing.
clearly
Yeah.
clear. But some people are still violating the different matter. But as a
Now we also, another thing we find, since you're talking about the clean room, that is a modular OT. I don't know, there is no terminology of modular OT. It's very dangerous for the air because it is basically for easy installing and resetting. But modular OT is not good for the air actually, air or clean air, whatever you say.
here is a small difference in thinking. Okay, perspective thinking is there. See, when you have puff panels or in metallic panels, okay,
Hmm.
metallic panels don't promote growth of microbials. Their own paint doesn't come out. So modular
Hmm.
panel is one of the concept which has been brought into to minimize the painting work. I think this is first and foremost. Okay, normal brick wall with the painting definitely after some days it'll slightly some pieces of paint will fall down. That is
Hmm.
avoided in any puff panel. It's only by the puff panel, that's all. It's only puff panel. What I use normally clean room. They same thing they are putting in.
But these types of panel, they, because there is a very small gap which actually contain lot of dust.
No. See, dust will anyhow come, sir. Either the footwear or the dust will always come. Our duty is to minimize the dust accumulation. Dust entry cannot be 100% tolerated. I mean, cannot be stopped. You come with the OT trolley or something, it will have some dust coming with it. Human hair also coming with dust. Dandruff also dust only. Cannot what say 100% remove it. You can minimize it, but whatever is falling should not be carrying down the patient. That's what the emphasis is.
Correct. Thank you.
Any other questions, Saji? Somebody else?
I think, sir, all the question has been taken place and you have answered very well. So nothing is pending in the question side.
Okay. Now I will send these two files to ISHRAE Delhi people. Okay. So kindly share with all the participants. And one more thing is regarding this AHU installation and UVGI. Okay, both are very, very crucial things. Please do some, spend some time to go through them. Okay, already I sent to ISHRAE journal few months back to print. I don't know when they'll print. Okay, they'll take time because once in 2 months only the book is printed, and they have a lot of other printing matters also. So it'll take time, maybe 3 months or 4 months. I don't know when they'll print. So in advance, I am sending with this all these people. Please go through that and demand with all the clients, even for comfort AC also, that A2 shall be kept in a closed room only. Okay, and some more topics are there I want to share, but running out of time. Maybe next time, sometime we meet, we can have a better talk on that.
Definitely, sir. We will have definitely more session and would like to continue with you regarding this topic further also.
Okay.
So, moving further, we have in this panel D. Balakrishnan, sir. So, any message, anything you would like to share in this forum, sir?
Yeah, I'll put my mail ID and the phone number. Okay, people
Yeah,
can just say that.
yeah, definitely, sir. Yeah.
Um,
I thank ISHRAE Delhi chapter for giving us an opportunity. I thank Mr. K.D. Singh, Tapas, and all other ISHRAE Delhi chapter. So I thank Mr. Murlikant sir also for giving an excellent presentation today. So I thank one and all for giving this talk. Thank you very much, sir.
Okay, sir. Thank you very much. And is all programs is also supported by ISHRAE Chennai chapter, and we are thankful to you for this. Moving forward, we have Sudha Tandon ma'am from Perfect Air. Perfect Air is the sponsor for the day, so we are very much thankful to them. And I request Sudha ma'am to share something in this forum and request also for the vote of thanks for this session as over to you, ma'am.
Thank you so much, Tapasji, for giving me this opportunity. First of all, I would like to thank Murlikant sir for such an informative session. It's been wonderful to attend this. I'm sure the participants must have gained a lot. Specifically, your emphasis on UVGI, which is very important in view of the current situation, considering the COVID waves and the other waves that have come in, the emphasis on UVGI implementation and how and where it needs to be placed in our designing is very critical. And the way you have explained it, it's wonderful, sir. Clean room design is not simple. It's very difficult. It's a very technical and a complex chapter in itself. And while we design these clean room with utmost precision, when it comes to execution, sir has really highlighted it well, that maintenance of the system, filter cleaning, AHU placements, these are very, very critical points, ensuring that these clean room systems achieve its goal for which it has been designed. So it's designed for a long-term execution and working. So along with the high technical understanding that we need to have in terms of designing, we also need to ensure that we maintain these systems regularly, get them validated and tested by authorities, by proper companies, to ensure that the conditions are maintained, the classes are maintained, and the productions are not impacted at all. So it's really important, and sir has really emphasized on the key elements here. Thank you so much, sir, for this presentation, and I'm sure there is a lot that you have to share with us. So we really look forward to upcoming presentations by you. I would also like to thank Delhi chapter in ISHRAE Institute of Excellence for organizing this on clean room systems. Also, Chennai chapter for the support, and Balakrishnan sir for his presence, and the entire Delhi chapter for the event. Thank you so much. That's all, Tapasji.
Thank you very much, ma'am. Thank you very much for supporting this event and being with us. So,
And lastly, yes, I'm sorry. Lastly, I would say, I am from Perfect Air. We also deal and expertise into clean room systems across different industries in North India. So, if anybody has any related concerns in clean rooms, regarding clean rooms, you can also reach out to us, and we can definitely exchange knowledge and exchange our understanding around the subject. So, please feel free to reach out to us. I'll also leave my details here. So if anything is required, please feel free to reach out.
Madam, sorry, Murlikan this side. Very thanks
Yes,
for
sir.
you to come here. I had been always been promoting only for this flow through HOs. I never recommend the draw through HOs. Now, have you ever promoted blow through HOs or draw through HOs?
Sir, I will have to discuss this on with my technical team.
Okay, no
I come
problem,
from
no problem.
Yes, sir.
See,
Yes, sir.
there's many people think that draw through is less in size or like that. It's all nothing,
The,
all nonsense. Okay, you always go for blow through, either be comfort or a clean room, whatever be the application.
sure.
Simple thing is there is no water carry forward.
Yes,
This is
yes.
the always in positive pressure, and we should emphasize for this. Otherwise, humidity control or microbial control, whatever, everything will always go for toss, especially in monsoon and other
Yes, yes.
weather disturbances.
Sure, sure.
So
That I
please
think we
look into
really.
that. Yeah.
Yeah, thank you, sir. I will surely, I think offline we'll also get in touch on these technical aspects,
Yeah.
because in India, even we understand that the standardization in terms of designing of clean room is not as per I mean, it's not really written anywhere properly. So I think our technical team and your expertise should get together, and also Niladri sir, who came up with wonderful questions and suggestions. I think we should come together with some very important standards for clean rooms and indoor air quality, and bring about new Indian standardizations.
Sudha ma'am, I request leave your email address in chat box.
Yeah, I will do that. Yes, I will do that.
So anybody have any concern, further they can contact you directly. Email address of Murlikant sir is already there. Number is already there. Ma'am, you can leave out with the number also. Yes.
Okay. I have left my details.
Yeah. So it is
Thank you.
sudha@perfectair.in. Number is
Yes.
9873093601. So anybody can reach out in this email and number. Both the number and email address are there. So thank you very much. Anything else, ma'am, you would like to share, or should we close this session?
No, I think we can close the session. If anybody has any questions, anything, they can definitely put up. From my side, I think we had a great session, and I really look forward to more sessions from you, Murlikant sir. Thank you.
Thank you.
Final message from Mulkan sir. Please share final message and then we will.
Yeah, I really enjoyed this giving this program. In fact, in the same month, this is my second program. I think a couple of weeks back, I gave a small program on humidity control for industrial applications. The response was quite good. Here also, the response was quite good. But one thing is, I expected a lot of questions from various participants. I don't know, probably they were hesitant or they couldn't understand. I don't know. Fine, no issues. But number are given to the people. They can come up with the questions. I always have the urge to learn more, give and take both ways. So whatever I should share. And people, when I ask questions, people should do both the ways. This is so expecting. No problem. In the coming days, we can have further more interactions. It's quite good. Had it been a physical presentation on a room, probably I haven't spent more time on explaining more and more concepts. But okay, within the available time and technology, we could do the best we can. I really thank ISHRAE Chennai, Delhi, ISHRAE, all people and the participants to have joined this program from from their busy schedule. Looking forward to meet in the coming days further more topics. I got some more topics in the line. Piping is there, ducting is there, and so many things are there.
Correct, sir.
We can maybe organize gradually in every couple of months one chat like that. So every month will be difficult for me. At least once in 2 months, something fine. It could be.
Yeah, definitely. So we can align upcoming programs as well.
Yeah.
So we can release the calendar on that particular things also.
Thank you.
So thank you very much, sir. With your permission, should I close the session?
Yeah, please. Very nice. Thank you very much. Yeah.
Thank you, everybody. Thank you, all the panelists. Thank you, all the attendees.
Thank you.
Yeah, ma'am.
Thank you.
Yeah.
Thank you.
Thank you very much.